Alrighty, everyone. So over the last couple videos, we have been looking at writing equations of linear functions. And in this video, we will be looking at two specific types of linear functions. The first of which is parallel lines. You may have heard of parallel lines before. Parallel lines are two or more lines that never intersect. So for infinitely long, because lines are infinitely long, they will never touch. They'll never cross. And so the symbol for that is two lines up and down. So like you can say that line A is parallel to line B. This symbol right here, that means parallel. Okay, and so in that picture there, you see an example of two lines that are parallel. You'll see they're going on and on and on forever, and they're never going to touch. And that is because the criteria, so like what makes two lines parallel, well, there's two things. They have to have the same slope, but they also have to have different y-intercepts. Okay, so the same slope, that part right there is super important. Same slope, but different y-intercepts. Because if they have the same y-intercept, then they'd be the same exact line. So that's why they have to have the same slope, but different y-intercepts. All right, and the second type of lines that we'll be dealing with are perpendicular lines. And they are lines that intersect to form four right angles. So let's look at this picture first. You've got two lines, and when they intersect, they form a right angle. And the symbol for a right angle, like in a diagram, is that little box. So there's four of these boxes there. Okay, so these are an example of perpendicular lines. The symbol for that is an upside down capital T. So we could say like line A is perpendicular to line B. This symbol right here means perpendicular. Okay, and the reason I remember that symbol is that it's an upside down T. Okay, and if I drew an upside down T, then two right angles will form. So that's how I kind of remember that. All right, and the criteria here is that they have opposite reciprocal slopes. So it's a two-parter. They have opposite reciprocal slopes. So the opposite just means if it was positive, now it's negative, or if it was negative, now it's positive. Reciprocal, so remember reciprocal just means you flip the number. Okay, the denominator goes to the numerator goes to the denominator. So some examples of this, like if I say that the slope, so if it was 3/7, then the perpendicular slope is going to equal negative 7/3. So opposite of 3/7, so negative 3/7, reciprocal, you flip it. Okay, another example, let's do like, let's see here, negative 2/5. Then the perpendicular slope is going to equal the opposite of negative 2/5, which is 2/5, and then the reciprocal, so it's going to be 5/2. Let's do one more example, like let's say that the slope is 4. So the perpendicular slope is going to be negative 1/4. Okay, and these all here mean perpendicular slope. Okay, and these right here are like my given slope. So that'll make sense once we do a problem like this. But there are some examples of if you're given a slope, how do you find the perpendicular slope? All right, so in this first example, we are going to determine whether or not these lines are parallel And so remember with parallel, we were looking at same slope, but different y-intercepts. Okay, perpendicular, we're looking for opposite reciprocal slopes. And if they don't have either of those, then it's going to be neither. So since we're looking at slope, since that's the main criteria in this lesson is looking at the slope, we need to look at them in slope-intercept form. So we need to get these lines into slope-intercept form. And you'll notice in A, the second equation, y equals 1/3 x plus 2, that's already in slope-intercept form. But what I have to do is I need to get this first equation, 3x plus y equals 12. I got to get that into slope-intercept form. So all I have to do is move the x over. And I'm going to get y equals negative 3x plus 12. All right, so the slope here is negative 3. And the slope in my second line is 1/3. So you'll notice these are opposite reciprocal slopes. And so since they are opposite reciprocal, since it's both of those, you got to have both opposite and reciprocal. Since it's opposite reciprocal, these lines are perpendicular. Okay? Go ahead and try that next example. Example B, try that on your own. Alrighty, so you want to make sure, like in B, that first equation that you have gotten it into slope-intercept form first, and then you're looking at the slopes. So we will also use that idea in order to write new equations that are either parallel or perpendicular to a given graph. So, for example, in this, we want to write an equation in slope-intercept form for the line that passes through the point 4, negative 2, and is parallel to the graph y equals 1/2 x minus 7. So, my given slope, the slope that's given to me is 1/2. So then, what I'm going to state is, okay, if my given slope is 1/2, and I'm trying to write an equation that is parallel, then what I need is I need to figure out what the parallel slope is going to be. And the parallel slope, remember, parallel slopes are the same, so my parallel slope is going to be 1/2. Okay? And what I'm going to do now in order to write this equation is I'm going to take my parallel slope, I'm going to take the given point, and I'm going to write an equation. So let's do it in point slope form. So point slope form, remember that's y minus the y coordinate equals my slope times x minus the x coordinate. All right, and then when I simplify some stuff here, you get y plus 2 equals, and then I distribute on the right-hand side, I'm going to get 1/2 x minus 2. And then to finish this out, I'm just going to subtract 2 from both sides. I'm going to get y equals 1/2 x minus 4. So this equation right here is parallel to my given line. All right, so this right here, that's my given line. And the given line and the equation that I just found, the linear function, those are parallel. Okay, I'll throw my work up in slope-intercept form if that's the method that you prefer. Alrighty, there's that work in slope-intercept form. If you have any questions, make sure to jot them down. Let's move on to B. So in this one, I want to write an equation in slope-intercept form for the line that passes through the point 4, negative 1, and is perpendicular, so this time I'm perpendicular to the graph of 7x minus 2y equals 3. So I got to do some stuff to my given line. So given line, that's 7x minus 2y equals 3. I got to get this into slope-intercept form so I can figure out what my given slope is. So if I subtract 7x from both sides, next I'm going to divide both sides by negative 2. And so I'm going to get y equals 7/2 x minus 3/2. So it's a messy equation dealing with fractions, but that's okay because all I'm really worried about is my given slope. And the given slope was 7/2. Okay? And if that's my given slope, then what I need to do is my perpendicular slope that needs to be the opposite reciprocal. So the opposite reciprocal is going to be -2/7. Opposite reciprocal. All right, so now what I need to do is I'm going to take my slope and I'm going to take my given point. And to make our lives a little bit easier, I'm going to change our given point to 7, -1. All right, and then what I'm going to do is I'm going to write a new equation in point slope form to start. So I'm going to take y minus the y coordinate equals my slope, and I need to make sure that I use the perpendicular slope there, times x minus the x coordinate. All right, so then I'm going to minus the negative becomes plus a positive, so it becomes y plus 1 equals, I need to distribute on the right-hand side, so it's going to be -2/7 x, and then that's going to become plus 2. -2/7 times -7, that's going to be positive 2. Then to finish this out, just going to subtract 1 from both sides. I'm going to get y equals -2/7 x plus 1. And what I just boxed, that equation we just found, is going to be perpendicular to what I started with that given line. So these two right here are perpendicular. Okay, so that's what we're finding in this section. So I've got 2 practice problems for you. Make sure you try those and then check your work. Alrighty, so make sure you check your work on that. As you see what I'm doing, I find it very useful to state the given slope and then right underneath it state the slope that I want. So remember, parallel slope is going to be the exact same. Opposite or perpendicular slope is going to be the opposite reciprocal. So make sure your work matches mine. Ask any questions you got, and that is going to wrap up this video.